Okay, so I'll go through a few of the topics that will be related to the assignments that you guys have got. Now, the first one here is meaning of exponents. When you see these questions, for example, let's say that one here, right? What's the difference between 3 power 4 and let's say 4 power 3? What's the difference? Evelyn?
The numbers.
Which number? I mean, which one are you talking about?
3 4 times.
Yes, you times 3 4 times.
4 3 times.
And 4 3 times. So when you look at the number like 3 power 4, what is this called? This part of the power, this is called what?
Variable? No.
No, it's not variable. Alvina?
Expression.
The whole thing is an expression, that's correct, but just this part here, just the number 3.
Term.
Not term, something else. Something else. Starts with B. That's the base, okay? That's the base. 3 is the base and 4, right, raised to the power 4. So 4 is the index. Okay? So 3 is the base and 4 is the index. Index tells you how many times the base is multiplied together. So 3 power 4 means the base is 3 and it's multiplied by itself 4 times. All right, so it will be this one here. As opposed to 4 times 3 is like saying you have 4 3s and then you're adding them together 4 times. All right, so this one would be for this expression here. Okay, all right, and yeah, so you guys can go ahead and try to match that. Let's see, the harder ones would be, okay, what is 1 to the power 3, for example? If you have 1 raised to any power, what is this equal to?
1.
Equals to 1, yes. Why? Because 1 raised to any power, let's say power 10, it just means 1 times itself 10 times. And when you times everything by 1, it's, when you times 1 by 1, it's just 1. Okay? Trick question. Well, not trick, but like an important question. Negative 1 to the power 2. What is this?
Negative. Actually, 1.
1, why?
Because you're timesing negative 1 by negative 1.
Yes, because you times negative 1 by negative 1. And 2 negatives will cancel out the negative, right? So that would just be positive 1. So how about negative 1 to the power 3, Alvina? What is this? Not power 2, but power 3. What do you think? Negative 1, yes, this is just negative 1 because you would have 2 pairs of negative 1 which will cancel each other out, right? That would just be 1 and then you times by another negative 1. So the answer is just the negative 1. Okay, let's see, what is negative 1 to the power 100? Evelyn?
1.
Positive 1, correct? Whenever the power is an even number like 100, there will be all pairs of negative 1 times together. So it will just cancel each other out. So what's negative 1 to the power 1, 2, 3, Alvina? When you times it by itself, 123 times. It will be negative 1, yes, because this is an odd power of negative 1. Okay, all right, that's good. So yeah, that's it for this topic here. Exponents shouldn't be too hard. The next one would be power of whole numbers. Okay, so some of these these ones should generally be easy. Now I want to tell you guys that there is a trick for numbers like this. Okay, 2 power 4 and 3 power 4. So if you guys do something like, let's say 2 to the power 4, right? The trick is to break it up into 2 squared times 2 squared. Does that make sense? Yeah? Because using index law, you guys should have learned index law, I think. When you times 2 squared by 2 squared is 2 to the power 2 plus 2. Right? Yeah? Which is 2 power 4. Or you can think of it as 2 power 4 is 2 times 2 times 2 times 2. And then we do these 2 together. And then we do these 2 together. Right? So that would be 2 squared times 2 squared, or that would just be 4 times 4, which is 16. Right? That's a lot easier, right? As opposed to, okay, I'll show you some other examples later, but let's say 3 to the power 4, right? 3 power 4 is again 3, 3, 3, 3, 4 of them multiplied together, times 2 of them on each side, right? So that would be 9 by 9, which is 81. 3 power 4 is 81. Right? That's a lot easier than if you were to do left to right. If you were to do left to right, that would be 9 times 3 times 3, and that would be 27 times 3 up. Yeah, a bit stuck, like 27 times 3, you gotta kind of work it out on paper, or even if mentally, it's a little bit harder. Okay, so that's the trick to do with power 4 and something like power 6. I don't think they ask you power 6 here, but let's say if you get 2 to the power 6, right, it would be 2 squared times 2 squared times 2 squared. Okay, or that would be 4 by 4 by 4, so that would be 16 by 4, and you can just work out 16 times 4. And if you're used to it, 16 times 4 is, Evelyn?
Four. Actually, no. Wait.
16 times 4 is? What's the trick to do this 2-digit multiplication? If you were trying to do 16 times 4, right, you break 16 into 10 and 6.
Yeah,
And you times each of them by 4. So 16 times 4 is the same as 10 by 4 plus 6 by 4. Right, which is 40 plus 24, that's 64.
yeah, that.
Yes, that 64. Okay, so that's 2 to the power 6 equals to 64. So that's how you work out some of these more slightly trickier exponents. Okay, next. Power. Okay, this one, power of fractions and decimals.
I hate this.
It's not hard. It's not hard. What's the answer to this one, Alvina? What do you think? Do you know how to do this one? 2 over 4. Okay, that's one guess. Evelyn, what's your answer?
What she said.
2 over 4. Okay, and you are both wrong. There is an easier way to see. Remember, this one means that the base is 1 over 4 and the power is 2, which means it's the base, right? Whoops. This is equivalent to having the base times itself how many times? 2 times. And when you're multiplying fraction, you're just multiplying the top together and the bottom together. So that would just be 1 over 16.
Oh, okay.
Yeah. Or if you use the index law, what happens is, let's say this one here, right? What happens is that you distribute the power, the index, into each of the part of the fraction. So that would be 1 cube over 2 cube. Okay, using the index, I think one of the index laws.
1 over 6.
Not 6. 2 to the power 3.
Oops, I forgot.
What's 2 to the power 3? Avina, what's 2 to the power 3? 8, correct? Because it's 2 times 2 times 2. Yeah, so it's 1 over 8. Okay, so fraction is actually not too bad. The ones that are a little bit trickier would be these ones here. Okay, so you have to these ones you technically have to work, you have to multiply them together. So for example, let's say 0.1 to the power 3. What you're doing is essentially 1 to the power 3, and then you just multiply the whole numbers 3 times, right? And then because it's 0.1 times 0.1 times 0.1, there are how many decimal digits? There are 3 decimal digits, so you have to move the decimal place 3 times afterwards. So you do 1 times 1 times 1, which is 1, and then you move the decimal place 3 times. 1, 2, 3 goes over here, so that would be 0.001 is the final answer. Okay, I'll show another example. Let's say 0.2 to the power 4. So this one, you can do 2 power 4 first, and remember this one means that there are 4 decimal digits because it's 0.2 times by itself 4 times, right? So there will be 4 decimal digits, 1, 2, 3, 4. So at the end, we move the decimal place 4 times. Okay, essentially you count how many decimals. So this is the base 0.2, right? You count how many decimal digits are there in the base. And because this gets multiplied by itself 4 times, it's just, whatever that number is times by 4. So all of these questions is only up to 1 decimal digit. So depending on the power, it will tell you how many decimal places you need to move the dot at the end. So first you do 2 power 4, that will be 16. We did that earlier. And with 16, you will move the decimal place how many times? 4 times. 1, 2, so it starts over here, right? So that'll be 1, 2, 3, 4. Okay, because it's 0 point something, so yeah, 4 times, so that will be 0, 0 and 0, so that will be 0.0016. So 0.2 to the power 4 is 0.0016. Okay, all right. Next is, I'll give you another example. Let's say 0.6 squared. Okay, who wants to try this one? Can anyone guess what the answer is?
36.
36?
Yeah.
Not just 36?
Oh. 0.3.
0.36 or 0.36 is the right answer. Yeah, because again, one decimal digit multiplied twice, there will be two decimal digits, so you got to move the decimal place once, twice over here. All right, so it will be 0.36
Okay. Yeah.
after moving the decimal place. Make sense?
Yeah.
Yeah. All good? Yeah. Okay. Next one would be okay, order of operations. No exponents. Now these ones not too hard, but you guys just need to be very careful. So let's say this one here. Which one do I do first? Avina, which one do I do first? 6 plus 8 or 8 divided by 2? 8 divided by 2, correct. So these ones are easy, right? As you can see, as long as you make sure you do all of the division or the multiplication first. So it will be these two, right? And then this one would be 2 divided by 2 first. And this one would be...
Isn't it just BODMAS?
It's the BODMAS thing, yes, correct. And after that, this one, you would go left to right. Okay, now, this one, normally you guys are taught to do left to right? For example, 10 minus 6, which is 4, plus 2 is 6, right? Now, there is another way to do these kinds of questions, and that is to look at each of these as a term. So when I look at this main expression, terms are separated by plus or minuses, which means this expression has 3 terms. The first term is 10. The second term is minus 6, and the other one is positive 2. Mm-hmm. Yeah, so 10, negative 6, and 2. You can add the terms in any order, but you're adding them, not multiplying. Yeah. So for example, I can go 10 plus 2 first. That would be 12 minus 6, which would be 6. It's correct still. Okay. So doing left to right is only the easiest thing the teachers would tell you to get started with, but you need to start seeing these in terms of terms and factors. So for example, let's say this one here, this expression here, how many terms are there in the outer expression, Evelyn? Let's see if you remember. In the outer expression, not 4.
Oh wait, no. I mean, wait, outer expression.
Yeah, in the whole, when you look at the expression as a whole, how many terms are there?
Oh.
Sorry?
2.
2, correct. What's the first term?
7 times 3.
Correct, 7 times 3, and the second one is?
Negative 2 times 5.
Negative 2 times 5. Does it make sense, Alvina? Yeah? So term comes with is the sign in front of it. That's why the second term is negative 2 times 5, right? And because this is the multiplication, like 2 times 5 together is one term. And inside that term, this is a factor, 2 is a factor, and 5 is a factor. So you multiply 2 factors together, and technically another factor is negative 1. Right? It's negative 1 times 2 times 5. So that's negative 2 times 5. So yes, there are 2 terms, so you need to work each term out separately, and then you combine them when it's just a simple term like this question here. Okay, so this technique is a little bit more advanced, but these questions are not hard. Okay, these are not hard. I'm just teaching you guys the slightly more advanced technique. That's all. Okay, next would be, okay, let's see, order of operations. Yeah, okay. So for this one here, all right, which one do we do first? Let's say for this question here, 4 squared over 2 squared. Which one do we do first? Evelyn? The squared or the division?
The squared.
The squared always comes first. Okay, you always work with the power first, and then you do the division after. However, there is another way of expanding this one using index law. So this one, if I were to use index law and turn it into something power 2, what is it? What goes in here? Bracket something and then close brackets everything to the power 2. What is in the brackets?
8.
Not 8.
Oh.
Try again. Not 4. Avina, any guess? What goes in the brackets? If I were to use one of the index laws. Hint is a reverse of something we just did a couple minutes ago. Another hint, it's a fraction. What's this fraction?
4 over 2.
Yes, it is 4 over 2. Remember, if each part of the fraction, top and bottom, if they both have the same power, you can take out the power as a common power of both top and bottom. So if you do this one this way, 4 divided by 2 is just 2, right? And then 2 squared is 4. So it might make some of the questions a little bit easier.
Yeah.
Yes, some of them would be made a lot easier doing it this way. Now, this expression here, can we do that? Can we take out a common power?
Yeah.
Yeah, what's a power?
Actually,
that we
no.
No, because the powers are different. The indices are different. That's 4, that's 2.
Yeah.
So you can't, right? So this one you need to work it out like normally. And this one would be 2 power 4 is 16. 4 power 2 is 16. So that would just be 1. So that would just be 1 there. Okay? So yeah, so that's what you will need to do for these questions here. Just remember, always do the power first if you can. Right? That'll be the most straightforward pathway. Always do the power first. And especially when you have like plus like that, you just have to do the power first. So that would just be 4 plus 4, which is 8. Okay, so these questions are tricky because they give you many different like versions of it. So be very careful when you do these ones. Okay, any question?
No.
No, Alvina? Yeah, all good. Let's see. I think this is the last one. Let me double check. See if this is the last one that you guys were assigned for the first half. No, not yet. Order of operations with fractions and exponents. Writing expressions with variables. Okay, hang on. Okay, all right. Now, I think I can't remember if I assigned the other ones to everyone. Maybe I didn't. Okay, anyway. So next would be these ones here, variables and expressions. Part of algebraic expressions. Okay, yeah, this is the tricky one. Yes, this is the tricky one. All right. Okay. Yep. Okay, now I think this is the one that you guys will most likely will have some trouble with. Look at this one first. Viv and Ian were trying to describe part of the expression 5 times x plus 7. So this is the expression here. Viv said the entire expression is the product of 3 factors. And Ian said on its own, x plus 7 is a sum with 2 terms. Now, in this one, let's see. The entire expression, which is this whole thing here, the product of 3 factors. Is it right?
Yeah.
No. It's not right. It is a product of 2 factors only. What are they? Because they are 5 and x plus 7 together. Okay, so as a whole, it's just 5 times x plus 7. So I see it as 5 times by x plus 7. So this is one factor. This is together is a factor. Right? But then on its own, right? On its own, x plus 7. So you look at only x plus 7 here. It's a sum with 2 terms. Okay, is it 2 terms in here? Yes, the 2 terms are x and 7. If you only look at x plus 7. So this is the kind of language I use a lot. If I say terms and factors, I normally use it very accurately. So you guys need to know how they differ. What is a factor? What is a term? So this topic will help you guys understand and practice seeing all the factors and terms in an expression, because later on when we do harder expressions, you need to move factors and move terms around like quite a lot, and you don't see just a number. Okay, it'll be more than just that. So for example, this one here, let's see. Estelle said the entire expression is a product of 2 factors. Is she correct, Alvina? For this one here, the entire expression is a product of 2 factors. Is that correct? Yeah, that's correct. Good. And then Evelyn, Isaac said on its own 4a plus 1 is a sum with 3 terms. Is that correct? No, what should it be then?
2.
2 terms, yes, that's right. That's 1, that's 2. So that's wrong, that's correct. So you gotta pick only Estelle. Yeah. Okay? Okay, alright. I think when you guys get to the actual questions, if you guys don't understand, I'll go around and help. But yeah, so that's I'll wait until you guys get to this one. So that's part of algebraic expressions, and then okay. Evaluating expressions with 1 variable. Yeah, I think this one should be easy. You just substitute the values in. Variable with okay. All right. So for these kinds of questions, right? Evaluate expressions for, let's say, x power 5 over x power 2 for x equals to 2. So if I were to substitute this into that expression, what would that be? What would that look like, Evelyn?
2 to the power of 5 over 2 to the power of 2.
Yep.
2 squared.
2 squared. Okay. And Alvina, what would you do when we see something like that? What's the next step? All right. Tell me the idea first before you do it. What's the next step?
You have to subtract the power.
Simplify the powers. Very good. How do you simplify that?
5 minus 2.
Very good. It's 2 to the power of 5 minus 2. Okay. So you guys should. So if you guys saw that the bases are the same, then you should think about combining the powers. When you divide, you're subtracting the power. So that's 2 to the power 3. Much easier to work with than 2 power 5, and then you have to divide by 2 squared. Okay. So that's a little trick when you guys are doing these kinds of questions. How about this one here? So this one, when you sub it in, it would be 7 squared over 3 squared minus 2. What's the next step then, Evelyn?
Do you do the same thing and then minus 2? Actually, no, never mind.
What's the next step then?
You power it.
Yes, you solve the power, right? So what would that be? So the top would be 49, and then the bottom would be 9 minus 2, which is 7.
Yeah.
Okay, so actually if you saw the bottom 9 minus 2, which is 7, you can keep the top to be the same. So that would be 7 squared over 7.
Okay.
And so you can just subtract the power, subtract the index instead, right? So that's 7 to the power 2 minus 1, which is 7. That's it.
Yeah.
Or 49 divided by 7 is just 7. Okay, so if you see expressions like that, you just need to expand the power, just resolve the power, and that's it. Okay, so these ones shouldn't be too difficult. Evaluate expression, multiple variables. Let's see. Yeah, so for this one, when you substitute the values in, make sure you substitute the correct value. Yeah. So for example, this one has F, G, and H. So you've got F here, G here, and H here. Just make sure you substitute in to the right place. So that's not too difficult. Okay, this one, fractions and decimals. So some of these would have a fraction. So for example, let's say this question here. E over 4 plus 2F, and F is 1 over 2. So technically, when you substitute it in, you can either write it in brackets. So for example, when you sub it in, it would be 12 over 4, and 2 times F is 1 over 2, so that would be plus 2, and then I can write the brackets 1 over 2. So 2 brackets 1 over 2 is the same as 2 times 1 over 2. Okay, so when the value that you're substituting in is a little bit complex, you can't work it out straight away, you can put it into brackets like that first, and then minus 3, and you can continue working through it as usual. Similarly, let's say this one here, right? If you don't want to work out 8 times 0.25 straight away, you can just rewrite it as 8 times 0.25, and then minus k, which is 1, and then plus 14. And then now you've substituted everything in. You can work this one out, and then you combine the rest of it. Okay. Yeah, I think that's about it for these ones. Just make sure you sub it in, and remember how you guys used to do decimal number multiplication, because you got to apply that now. Okay. Now note that some of these decimals, right, you can work it out a lot easier if you convert them into fractions. So for example, the 0.25 here, so let's say I go back to this question here. 8 times 0.25, and then minus 1 plus 14. Remember I mentioned earlier where these two are terms, right? So that's 1, 2, 3 terms in the whole expressions. I can combine these two terms first. Okay, so I technically can combine these two terms, -1 and 14 first, and that would be
13.
13, yes. So that would be plus 13. Alright, make sure the plus because it's a term. So if there's no sign, it just means it's plus in front of it. Now 8 times 0.25, what's 0.25 as a fraction? What's 0.25 as a fraction, Alvina? 1 over 4, correct. When you multiply a fraction, Evelyn, what do we do? If it's a whole number times into a fraction.
Don't you times it and then add it? Like, wait.
What do you mean?
I mean, never mind.
Okay, what do you think is 8 times 1 over 4? Hint, it's very easy.
12?
No.
Oh.
When you're multiplying a whole number with a fraction, you're only multiplying the whole number to the top of the fraction.
Oh, so 8 over 4.
It is 8 over 4. Because 8 just means 8 over 1, right? And when you multiply 1 by 4, it's just the same. So that's why if it's a whole number times a fraction, you only multiply it to the top number of the fraction only.
Yeah.
Okay, if you have a whole number. So that's just be 8 over 4, which is 2. Plus 13 is 15. Okay, another example would be, say, this one here. 13 minus that. Now, when I substitute the values in, 0.75 is what fraction, Evelyn?
1, no. Actually, I don't even know.
0.75. Alvina, what's a fraction? As a fraction, 0.75.
Is it 1 over... Actually, I don't know.
Not 1 over. 3 over 4, yes.
Oh.
Because 0.25 is 1 over 4. When you add that 3 times, right, it's 0.75, right? Because 0.25, 0.50, 0.75.
Okay.
Right, so that's 3 over 4 times W is 12, so I write it that way. And then plus 8 times X, which is 1 over 2. What's 8 times 1 over 2? Alvina?
Wait, which one?
8 times 1 over 2, this one. Work this one first, that's the easier one.
8 over 2?
8 over 2, yes. Okay, we'll simplify that later. Now, this one though, 3 over 4 times 12. What do we do with it first? Yeah, let's focus on this one. 3 over 4 times 12. What do we do with this expression first? Evelyn? If I'm asking that, it's definitely not multiplying the top together. Yeah, do something else.
Divide?
Divide
Yeah, I
what?
mean, make the 12 over 1 and then... Actually, no, I don't even know.
12 over 1 and then? Let's say you do that and then?
Yeah, and then you do that opposite thing.
Yep. So you're simplifying the fractions. What numbers are you simplifying here?
The 4 and the 12.
Yes, you look at the 4 and you look at the 12 and then you simplify them, right?
Mm-hmm.
Simplify by, Evelyn, continue.
1. Wait, no, I mean... 4 would be 1, right?
4 would be 1, correct? And then 12 would be?
3.
12 is 3. That's right. Alvina, any question there? No, we're just dividing them both by 4, right? So that would be 3 over 1 times 3 over 1, which is 9. That's it.
Yeah.
Okay? So when you see a fraction multiplication that has big numbers, see if you can simplify that first.
Okay.
Okay, so that would be 9 and then 13 minus 9 plus 8 over 2 is just 4. Right? Either work left to right or you can go 13 plus 4 first and then you minus 9 after. Either way, you should get the same answer. Okay, so that's the trick when you're substituting the decimal numbers in. So if you notice, these are all the questions, okay? As the all of the possible questions you guys would see. That's why I'm going through many of them now. But these ones, you see how these decimal numbers, you can always convert it into a fraction, right? 0.5 is 1 over 2, 0.25 is 1 over 4, and the other one, 0.75 is 3 over 4. Convert to a fraction, it will make the thing a lot easier. You don't need to do multiplication of decimal number.
Okay.
Okay? It'll make things a lot easier. So yeah, evaluate the expressions and then let's see, expression value. Okay, this one, expression values intuition. Okay, this is a tricky one. All right, let's have a look at this one here. What happens to the value of the expression 20 plus a as a increases? You guys got to think for this one, okay? What happens as a increases? It stays the same. Is wrong.
Oh.
As a increases,
Increases.
it will increase. Okay. So the idea is this. If you think about, just use an example, right? Let's say 20 plus 2 is 22. As a, which is that value, as it increased to 20 plus 3 is 23, right? And then 20 plus, let's say 5 is 25. So as a increases, the whole thing would increase. Now, how about this one here? 100 minus x as x increases. Right? As x increases, okay, so x will get higher and higher. What would happen to the main expression?
Decreases. Wait,
Why?
no. Actually, I don't.
No?
It stays the same.
Stays the same. Okay, Avina? Increases. So Avina, Evelyn, the answer is it decreases.
I said that the first time.
Then you change your answer. You gotta hold fast to your answer. Why? So let's have a look at what happens when x increases. So let's say we choose x to be 1, 2, and 3. right? You have 100 minus 1, it is 99. 100 minus 2 is 98. So when you're subtracting by a bigger number, the whole expression becomes smaller and smaller. Okay, so that's why as x increases, 100 minus a bigger number becomes a smaller number. Okay? Yeah? So these ones are a little bit tricky. Oh, okay. This one, 10 over d, right? As d increases from a small positive to a large positive. Would it increase, decrease, or stay the same? Now, I'll tell you guys, it doesn't stay the same. It's either increasing or decreasing. So as x increases from small positive to large positive, it just means that as d goes from, let's say, 1 to 2 to 3, what happens for the expression 10 over d?
Decreases?
Decreases.
Yeah.
Or increases?
Decreases.
Decreases. Alvina, decreases or increases?
Increases.
Decreases. Why? Alvina, explain.
Increases.
Increases? Explain.
Because maybe 10 would be times by the d.
Almost is divided by d. So you thought it was a time, that's probably why you thought it increases. The answer is it decreases. Because when you're dividing, right, the larger the number d is, the smaller the value will be. It's like you have $10, you divide it to 1, just yourself, you get 10. If you divide it among 2 people, you get 5 each.
Yeah.
Alright, so the value decreases if you have to divide by a larger number. Okay, so be careful, this is division, not multiplication. This one though, what happens to 3e as e increases? What happens to 3e? Is it A, B, C, or D? Which one? So A, B, or C? A, B, or C? What happens to 3 times e? Any confident guess?
Increase.
Okay, Evelyn got increase. Avina, what do you think? Increase or decrease? Increase. And yes, that would be the correct answer. So let me see if it's calling me. No. Yes, it would increase, right? Because like 3 times the number, if the number gets bigger, the whole product gets bigger. So yeah, this is about expression value intuition. You will need to, some of these are quite tricky. Okay, I'll let you guys try it out. Okay, I won't give you guys all the answer yet. I'll just give you guys maybe one more. This one. This one here. As x decreases from a large positive to small positive. So note that x is decreasing. It's positive, but it's decreasing. So when I see this, okay, if x decreases and 5 divided by a smaller number, right, then this whole thing will increase. And then the plus 5 doesn't matter. It's just, whatever the plus 5 is still the same. So it will increase the entire expression. So if that increases, then the whole expression will also increase. Okay, so these ones are a bit tricky, but this intuition you will see that I think next year. You'll see questions related to these ones next year, and definitely in year 11. Okay, let's see. If word problems, writing expressions. Okay, so one last topic, and then I'll get you guys started on it. Nah, this one should be okay. Okay, I think that should be it. So get started on the questions first, and then I'll help you as you go. So Hannah and Selena, if you're listening to this recording, please get onto your assignments. Get onto your assigned task first. All right, and then see how you go.
Can I use